Welcome. Today we will be taking a look at the notes worksheet entitled Hyperbolas Day 2. It is definitely time for us to build on the foundation that we developed yesterday, both with the geometry of a hyperbola and the algebra with a hyperbola. And so we'll expand that out a little bit today and do some more of the complex algebra on the coordinate plane. So it looks like I have a couple investigations to get us thinking in the right direction here. It looks like specifically with these asymptotes, and we'll go ahead and do that and then get into some other things here as well during the lesson. So let's start it out. The investigation at the top says asymptotes of a hyperbola, horizontal first. And if you get a chance, because we're going to obviously work a lot with the center off the origin, but in this case, let's go center at the origin. So I gave us a grid to just make it a little easier potentially, but if you get a chance, put a little X just at the origin right there, just being our center. And then let's go ahead and get some points here, everyone, if you would. So because this is horizontal, what I want us to do is let's go horizontal to the vertices. And I don't care, however many units you'd like to go, that's fine by me. I'm just going to go probably about 3 out there, just give or take. It doesn't matter. Just go in this many units one direction, then go that same units the other direction, something like that would do. Okay, good. And then when you do get a chance, let's get those endpoints on the conjugate axis. That's what we had to call those on the previous lesson. So let's go up however many units you want. And actually, I'll put a little X right there. And same, just make sure you mirror it. Something like that would do. Hope everyone's comfortable with that piece. And the whole reason for doing that, the 2 vertices and the 2 endpoints, is I want to really go ahead and be able to draw my rectangle. So the asymptotes, if you remember, are all based on the shape of that rectangle because our asymptotes go through the corners of our rectangle and the center. And so let's go ahead and do that when you get a chance. I've got that. There's one asymptote. So one asymptote is an inclining line. The other asymptote is a declining line. Looks good. I actually do want to model those. So here's what I'm thinking if you get a chance. Not that this matters, but just a refresher, that's what a horizontal hyperbola would look like, something like that. Horizontal hyperbola, 2 branches. That's great. And if you remember, the arms of each branch, are getting infinitely close to these boundary lines, and those boundary lines are based on the rectangle that we drew. Okay, good. All right, guys, well, let's go ahead and do y equals mx plus b on your paper. Underline the m, underline the b. I want those 2 things. So we're going to have to actually come up with 2 equations, basically. We'll see if we can consolidate it, but 2 equations for the 2 asymptotes that you see on the grid there. So let's start it out nice and easy. One of those 2, either m or b, is basically jumping off the board at me. And I'm kind of looking at this and thinking, oh, well, you know what, nice and easy there. For each asymptote, the y-intercept is actually just the center, which happens to be the origin. So this y-intercept is right at 0, 0. Let's put that in. That's great. Makes it pretty easy, doesn't it? Because we're just going to have a plus 0 on the back. Everyone okay with that? This line goes through the y-intercept at 0. This line goes through the y-intercept at 0. All right, now let's focus on that slope. So the slope, if you remember, is rise over run. And that's what I want here. Okay, so let's see if we can put some stuff in. Forget numbers. Let's go be a little more general with this. And let's think about the letters from yesterday. I guess I would argue that we have a center and we have a vertex. Guys, that's A. Why don't we throw in a little A right there? And I had a center and I made you put an endpoint on the conjugate. Hey, that's B. That's right up there. Now, here's what I guess I would ask you. Is there a way, and you could pick any 2 points you'd like, but is there basically a way to come up with a little rise over run from maybe here up to here where that happens to go? So this is our inclining line. Why don't we take care of that one first? What is the rise over run? Well, it looks like from here to here, nice and straightforward. I'm rising up B to get to this endpoint, and then I'm running over exactly A to get over here, which would be the horizontal piece to the vertex. So I'm seeing this as a rise over run of B over A. Okay, that's one line. How about the other one? So in this case, what about that declining line? Same deal, except I'm going from here maybe down to here. What's the rise and run as I go down there? Well, in this case, I'm just going down to the endpoint on the conjugate as I run over A. So down B over A. Does everyone kind of see that? I'll highlight one more time. Down B over A, and that would be the rise over run. And if I'm going down B, we'll just call it the opposite of B over A. And I think those are your two slopes. So I said we might be able to consolidate the two equations, and I think we're going to be able to do that. Why don't we throw a little plus or minus out in front? And so there's your slope. And if you want to put a plus 0 on the back, but obviously totally not necessary, I think nice and straightforward, those are your two equations for those two asymptotes right there. Great. Let's repeat. Let's do it the same now with the vertical one. So it's going to be similar, but just careful of the subtle differences. All right, this one I think we can go a little faster maybe. Give me a center at the origin. Do the same thing. Let's go, because it's going vertical, why don't we go up those, however many we did it before, and it doesn't matter if you don't want to, but go up and down the same amount. Give me two vertices. And go left and right the same amount. Give me two endpoints. So that obviously is the major difference here. Because it's vertical, we're going to go vertical to the vertices. But, the rectangle is basically going to look the same. So when you get a chance, give me that rectangle just like that. A couple asymptotes would do for our two branches there. So one that way, and how about one that way? Now the vertical one, just good little practice, sketching our hyperbola, something like that would be great. And then opening downward as well, something like that. Not too bad. Okay, you could potentially, just based on what we did previously there, come up with this right away, but if you can't, no worries. Let's talk our way through it. I want y equals mx plus b's for both, and I would start with the same situation. I'm seeing a y-intercept at 0, 0, so I'm going to write that right here. So not a problem there. Our b value, this b value I should say, our y-intercept is going to be 0. That's not too bad. The key, I think, everyone, is coming up with a little rise over run for this. And take a look at that nice, subtle difference from this diagram and this diagram. I'm thinking rise over run from here to here might help us out. And in this case, let's make sure we label correctly. If I'm rising here, it looks like I'm going to a vertex, so that's A. And the run part over here, the horizontal piece, that's to the end point on that conjugate axis, that's B. And so that, I think, is our difference. I'm hoping you see, because it's vertical, we rise with A and we run with B. And so that, let's do a little plus or minus. As you know, that's probably going to happen here. That would be the case. And now we're ready. So you'll have to just be able to distinguish between the two variations here. But in essence, if it's a horizontal one, you're rising B and running A. If it's vertical, yeah, you're rising to the vertex. So you're rising A and running B. Awesome. We'll probably do this, if I remember correctly, on example 2. But keep that in the back of your mind. We're actually going to see this again on the next notes worksheet. And it's going to get a touch harder because we're going to take the center off the origin. But for right now, yeah, not too bad. All right, let's get just a little review problem going. So it says, sketch the graph for the equation, use asymptotes to establish boundaries for each branch, and then let's include the foci as well. Okay, nice. Why don't we just start it out? You're going to be doing this when we take the center off, so let's include the center. Center is at 0, 0. So everyone, if you would, just a little X right there, right in the middle. And you can do this however you'd like, in any order. I'm just going to go vertices first. Seems to be a good course of action. Couple things that I see, and I guess I would ask you this before I jump the gun. Is our A value going to be 3, or is our A value going to be 6? Look at that equation, and what are you thinking? I'm seeing the A value is 3. based on the way we defined our equation for a hyperbola. A is 3. I would ask one other question as a follow-up. Are we going up and down to the vertices or left and right to the vertices? And if you remember, it's all out in front. A is out in front, direction is out in front, and because it's the y that is out in front, we're going up and down. So just from the center, which is in this case at the origin, we'll be careful on when it's not, but just up 3 from the center, down 3 from the center. Hope everyone's okay with that. Good start. Next piece. I'm not going to write it out this time. You'll have to excuse my shorthand. If you want to write it out, that's fine. Endpoints of the conjugate axis. I'm afraid we don't have anything better than that. Here's my b value, of course. And if a was the 3, then the b is going to be the 6. Hope everybody realizes that. And if we went up and down to the vertices, then you know we're going left and right to these endpoints. So let's do exactly that. Let's go left and right there. Coming off the center, I'll go left 6. 1, 2, 3, 4, 5, and 6. Put a little x. 1, 2, 3, 4, 5, and 6. Put another little x. And I'm hoping you saw that those 2 points, not too bad. They get labeled pretty well there. Negative 6, 0, and positive 6, 0. And I probably have enough to get a good sketch on this. So, you know, that rectangle really sets up the boundaries for our curve. So let's go ahead and get that rectangle in place. And let's go ahead and now draw the asymptotes right on through the corners and the center, something like that. And let's come at it this direction. There we go, not too bad. This looks to be a vertical one, as we mentioned. Going that way, going that way. Pretty wide one, actually, now that I'm looking at that, and that's just on the relationship of A and B. And that's looking pretty good. There are 2 branches of our hyperbola. I'd probably ask us to do one more piece if we could, and let's go ahead and get foci on this. So foci definitely is C. Good refresher from yesterday. In a hyperbola, as we all remember, it's actually a squared plus b squared. So it formulates nicely with what you know of the Pythagorean theorem. And that looks good. So remember, C is always going to be bigger than A. So we want to add this on top of A. That's the key. So in this case, I'm getting a 9 plus 36. Not too bad with the math here. C squared is 45. C is equal to the square root of 45 if you want to write that down. I like simplifying things, but that would be probably 3 root 5. If you want to include a plus or minus on that, that's fine as well, as we do want to obviously include both directions. But you know, I will leave that to your discretion. I guess I would ask you this before we go ahead and place those 2 foci. Up and down to the foci or left and right to the foci? And I'm hoping you would say up and down. Same direction as the vertices, along the transverse axis, just past the vertices, of course. So in this case, square root of 45, I don't know, is probably somewhere in the 6.7, 6.8 range, give or take there. So we would add to the y, so we're going up, subtract from the y, so we're going down, and I think those are our 2. I'll try to place it to the best of my ability here, but shouldn't be too bad. Let's see. 1, 2, 3, 4, 5, 6, and give or take close to the 7. Same, 1, 2, 3, 4, 5, and 6, close to the 7, give or take. Nice. I would ask us to do one more thing. You're basically done at this stage, but you know, just to refresh from yesterday, of course, have to do it. You know, if I pick a point anywhere on the hyperbola and I measured it to the one focus, then measured it to the other focus, and picture yourself subtracting the 2 distances. Would it be constant for anywhere on the 2 branches? Yeah, it would. So that was the idea. The difference of the distances is constant. Great. Putting it all together. It looks really, really nice up here. Good sketch. I'm hoping it's all clicking for you. Let's go get 2. I like this one, and it does relate nicely to the investigation at the top of the page. So let's see if we can put it together. Find an equation for the given criteria. Center, 0, 0. Vertex, 8, 0. Asymptotes, here's the key. Asymptotes have that equation right there. And actually, I'm just kind of thinking off the cuff. You know, a slope is a rise over run. You want to put that 2 over 1 for me? Make it maybe a little easier to interpret. And I don't know, I think this is maybe even a redundancy here, but it is opening horizontally. And I think we knew that if you look at the center and you look at the vertex, we are moving horizontally between the two. So, you know, the transverse axis is horizontal is another way to say that we're opening our hyperbola horizontally, left and right. Okay, cool. Why don't we set up the template, 2 fractions with a minus equal to 1. And, you know, I would start with this part here. We need A, we need B. I don't know if C is into the mix, so I'm just going to put them out there and see what we have. And then let's try to, what I like about this stuff is just you're using one piece of information and then to get more information. And from there and there until you have enough to write the equation. Well, one thing I know definitively, out of these 3 variables right here, it looks like 1 is just really given nicely. It looks like A is 8. Center to vertex, 8 units. Beautiful. Now, I think we're going to have to work with these other 2 if we have to get those. Let's see what the other information is. Asymptotes, guys. There's the equation. And so what I need you to do is think about it this way. We talked about this as a rise over run situation, and it connects to the A's and B's values from the hyperbola. So the question is, which is it? Is this 2 over 1, is it A over B, or is it B over A? And if you look at the top, I think we developed the fact that if it's horizontal, and I'll go back just real quick here, if it's horizontal, then our slope is B over A. And you could picture it. If it's horizontal, we're running to the vertex. So we're rising to the endpoint of the conjugate. So B over A. And so what I see is, in this case, that 2 over 1 is the B over A ratio. And so just be careful. It doesn't mean that A is definitively 1 and B is definitively 2. That's where you have to be careful. But it means that's the ratio of B to A. And I already found that A was 8. So that one was given, and now obviously we would solve for the B. So this is what I'm thinking is our setup right there. The 2 to 1 ratio is B to 8. And so without a whole lot of issue, I'm seeing B is 16. Now, as a matter of fact, I don't think we need that. That's not part of the equation. We're not graphing. We're not asking for the position of the foci. So, get rid of it. Well, we have enough. So it would be great if you could take a moment and can you write the equation? See if you could pull that off, and then come on back and see if you got it right. Well, first order of business, and we probably could have done this at the outset, which variable goes out in front? Well, we know it's horizontal, so the x is out in front, the y is behind. So that, I think, was kind of given initially there. We could have put that in place. And then, obviously, in this case, we're going horizontally to the vertices, and we're going 8 units. So a squared, always out in front for a hyperbola. And the b squared is always on the back for the hyperbola. And so 16 squared would be 256. And I think this satisfies all the criteria given. That looks perfect. Okay, good. I'm going to move on to my next board right here. It looks like we need to get our standard form one more time and then do example 3 to kind of put it together. This looks great. So if you would underline standard form, horizontal. Now here's the key. Center no longer at the origin, but there it is one last time, H and K. And standard form, vertical, H and K. All right. So here's what I have. Same deal. Shouldn't scare you here, just one added layer. So 2 fractions with the minus in between. If it's horizontal, you know the x is coming out in front, but instead of x squared, of course, it's x minus h squared. A always goes out in front with the direction, horizontal, so there we go, and then y minus k squared on the back with your b squared down below. Second one, of course, is the vertical. Only one thing is going to change. Please remember k always goes with the y, so it'll look like this, h and k, so y minus k squared over a squared, and you knew it's coming, the x on the back with the h, and that should do. All right, you might want to box those up in some way, shape, or form. If I didn't leave you enough room, my apologies. I think I've got enough to work with right here. Let's go get 3. Let's see if we can really put it all together. We'll use the grid if we need to kind of count out some things. I don't necessarily know that I'll go in this particular order. We'll just kind of start it out and see where it leads. So here's our equation. Looks good. Let's start with letter A, though. Does the hyperbola open vertically or horizontally? And I'm hoping you would just look out in front, and because the y is out in front, you know it's opening vertically, excuse me. Okay, good. So opening vertically, I think we should kind of get our center point. Everything is going to go from there. And HK, just be careful, HK, HK. Nice. So I'm seeing the center at 1, 2. Just make sure you have that piece. That looks pretty good to me, so I'm going to go ahead and put our center in place, 1, 2. And remember, everything is going to be generated off the center. So that's a good start for us. I will go vertices and then endpoints and then maybe sketch and then do the foci. I don't know. We'll just kind of see where it leads. Well, let's go get the vertices. If you don't need to write all this stuff out at this stage, that's totally fine by me. Just do what you need to do to be successful with it. I'm seeing an A value of 2, and we already determined it's opening vertically, so we're going to go up and down 2 units from that center. Now I'm going to try this without the grid with you, and if we need the grid to go ahead and confirm or whatever, we'll go ahead and do that. But remember, on the coordinate plane, we've talked about this before, which coordinate changes when I move up and down on the coordinate plane? Well, it's the y coordinate that changes. So from the center, I'm going to go up 2, so 2 plus 2 is 4. And from that center, I'm going to go down 2, and 2 minus 2 is 0. So I think that's where we're going to place our 2 vertices, and here's the up 2, here's the down 2 right here. Great. Again, I'm just going to shortchange this piece. Endpoints, conjugate axis. Let's get it from B. Hoping you see B is 4. And you know, of course, we're going left and right. Good. Let's go ahead and see if we can figure out those locations without actually counting it out. If we need to, so be it. From the center, guys, always from the center. If I'm going left and right, we do know the x coordinate is going to change. So in this case, if I'm going to the left, I'm going to subtract 4. So it looks like 1 minus 4 would be negative 3. And then 1 plus 4 would be positive 5. So again, you can kind of see that here. If I go 1, 2, 3, 4, 1, 2, 3, 4, you kind of get a sense of it. And if you need the grid to go ahead and count it out and then give me the ordered pairs, that is totally fine, of course. Whatever works for you. Hey, let's get that rectangle in place. Good. Asymptotes, ready to go. One right there. And one right there. Probably sketch this out a little bit too. I think we certainly have enough information. This was a vertical one. Again, pretty open actually, all things considered. Not that narrow, pretty wide. That looks good. Let's get those foci in place. Let's just see what we have. So foci, I'm going to go down right here and just do my a squared and b squared again. By now it should really be clicking nicely. All these equations work out perfectly well. How about a 4 and a 16 added together there? C squared equals 20. C is equal to root 20. I like a 2 root 5 on that, but obviously express it however you'd like. Totally your call. If you go decimal, I can live with it. I'd prefer exact, but whatever. So foci, let's start with the C value being 2 root 5. Don't forget, we are going to go up and down for those two foci, obviously the direction that it opens. And again, just be careful. When I ask you for the foci, don't just give me this. Give me the position. What would be the ordered pairs? So let's see what we have going on there. We are going up and down. And so which coordinate off that center is going to change? Got to be the y. So again, if we're going up, I would add to our y value. And if I'm going down, I would subtract from our y value. I've seen students over the years, I think we talked about this before, kind of put this together. If you wanted to write this as 1, comma, 2 plus or minus 2 root 5, that is of course fine. That looks great. Cool. I'm going to go ahead and just count it out there. Root 20, maybe about 4.4, 4.5, somewhere in there. So I'll just go ahead and put it in place roughly where it would go. 1, 2, 3, 4, maybe in there. Same from the center. 1, 2, 3, 4, and a little more. Looks good. There are your two foci. Cool. Hey, let's go get one more piece. Let's see if we can pull this off. And then let's see, we'll do example 4. I think we'll go all the way through in one way for letter A, I'm thinking, and then letter B we'll just change it, but we won't go through all the motions of finding the characteristics there. All right, guys, you knew it was coming. We've got to convert one to the other, general to standard. And let's see, strategies to convert. Notice, of course, it's all coming down to completing the square. Set the equation to 1. And just one thing, guys, I'll underline it, even though it's pretty much highlighted. We do have to be careful of the negative in front of a squared term. And I'll show you what I mean by that momentarily. Well, let's see what we can do with this. We have some good practice with changing all of these general forms to the standard form. And it's all based on completing the square. Let's see if we can make it happen here. Notice the subtle difference. In this case, we have a minus in front of one of the square terms here and here. So a minus in front of one of the square terms. By changing the plus from the ellipse to the minus, like this right here, that's what really changes the shape. From ellipse to hyperbola, just by throwing this as a minus. Cool. Okay, well, let's go for it. Complete the square on the x's. I'm going to do this in 2 steps like I have before. So that will be the case right there, y squared plus the 6y. Let's get rid of that 39. It's got to go. Let's start with these two right here. I've kind of done this before, circling it. I don't know if it helps or not, but let's take out the 4. So I'm getting an x squared. How does an 8x sound to you? Now it's ready to go. So as we've done this before, I think that works out nicely. I'm going to go ahead and circle it like this for just a second. And here's the thing with this one. There's no number in front of the y squared, but we are going to take out the minus. So that's going to be the key. That's what I said, careful of the negative symbol. We're going to take out the minus because remember, we just want a single y squared, right? So we're going to pull out the negative part to that so we can get just the positive y squared there. Now here, to me, is the key. When we factor out the negative, notice I do it from my circled terms right here. I factor it out here, I get y squared, and this is where I would see most mistakes. What do you think we're going to get here, everybody? Plus 6y or minus 6y? Minus. When we factor out the negative from there, it changes it to minus. Cool. Then we have the negative 39, and let's see what we can fill in on the back. How about a 16 here? How about a 9 here? And here's what's fascinating. What goes in that third blank? Oh my goodness. Now be careful. It's not just a 16 and 9 somehow added together, and that's how I balance. Let's be careful on that like we have before. I didn't add 16. I actually added 4 times 16. I actually added 64 here. So I added 64. Now here I didn't really add 9. I actually added a negative 9. Oh goodness. Does everyone see that? That's really a negative 9 that I've added. So as a result, I have a 64 and a negative 9 that I've added to the left side. That happens to be 55, and so that's what I'm seeing over here. That's the key. Okay, now I think we're ready. We complete because of the way it factors. There's the first one. There's the second one. Add those two together, and I'm liking a 16 on that. All right. Because it's a minus, it forms a hyperbola on the coordinate plane. I'm going to go ahead and throw in the division of 16. So let's get this to 1 right over here. Looks good. And just remember, we reduce. 4 over 16 does reduce. So that would be really a 1 over 4. So 1 times that over 4 minus, and this is just a 1 over 16, right? There's a 1 out there, and that doesn't reduce. So y minus 3 squared over 16. That's great. Hey, this would be really, really interesting to see. I'm just going to list these right here. Center, and I might have to kind of run this through a little bit. Vertices, endpoints of the conjugates, and let's see if I can find some room. How about foci? I'm all over the place here, but hopefully it'll work. Hey guys, if you could fill out those 4, no grid, that would be really quite amazing. Want to give it a try? Pause the video for a moment. Try it out. If you can do this, you're really on top of things. You really got it. Okay, here's what I have. Center, negative 4 and 3. Now the vertices, we're going horizontally. We're going 2 units off the center. And so what I'm seeing, of course, is we're going to go 2 units to the left, 2 units to the right. 2 units left would be negative 6, 3. 2 units right would be negative 2, 3. Okay? Endpoints of the conjugate. Sorry, again, see if I can fit that in there. We would be going up and down. So it's the y coordinate that's going to change, and it's going to change by 4. So we're going to add 4 to this, and we're going to subtract 4 from it. So I'm getting negative 4 and 7, and I'm also getting negative 4 and negative 1. So the b value is 4. Nice. Next one there, foci. See if you can run it through. I'm getting an a squared and b squared, so 4 and 16 make 20. Square root of 20 again. So c is equal to the square root of 20. I'm going to write that right in there. Square root of 20 is 2 root 5. Again, this is a horizontal one, so I'm going to add and subtract from the x's. So let's see if I can find the room. It would be negative 4 plus 2 root 5, comma 3, and then negative 4 minus 2 root 5, comma 3. And that is it. Look at that. No grid necessary, just using the equation and just pretty simple arithmetic to kind of pull it all off. Cool. Remember, horizontal, because notice which one is positive. Here, which direction is this going to open? Just right out in front. It's going to be vertical because the y squared is out in front, positive, and the x squared is the one that's negative. Okay, we won't go through all the motions. Let's just convert and be done. Be great if you could pause the video and just see if you got it right, but I will leave that, of course, to your discretion. I'm going to roll with it, though. So I've got that piece, and I'm going to circle them, kind of like that. And then, let's see, Got that right there. Going to circle those guys too. 63 is in the way. Move it on over. Well, although I didn't really need that blank just yet, I jumped the gun. Let's get rid of it. Okay, here we go. Take out the 9. Y squared minus 2y. Get that blank ready to go. Now here's the key. If you can do this, you're on your way. I took out my negative 4 from there, so I can get my positive x squared. That's the key. This would change to a minus 6x though. And now there's my 63 and the blank. So see that step. Make sure that really does work for you. Okay, here, add the 1. Here, add the 9. But what did you really add to both sides of this equation? Let's be careful. So here I added not 1, but I added 9. Here I added not 9, but negative 36. That's the key. That negative is a tricky one. Just be careful with it. So a 9 and a negative 36. A 9 and negative 36 combined together is a negative 27. And so that's what's going over there to balance. Minus 27. Okay, now it's rolling. Got that. Minus the 4. Factor that. X minus 3 squared. Here's your 36. There is your hyperbola. It's a great equation for a hyperbola. We like just setting it equal to 1. Just helps with the graphing, of course, because A and B are all right there for you when we do it. So let's go ahead and get that in standard form. Divide by 36, which means we're just going to reduce this piece right here. 9 over 36. If I asked you to reduce that, you would all tell me 1 over 4. So let's write it. 1 over 4. Here's your 1 over the 4. Here's my minus. If I asked you to reduce 4 over 36, you would all, of course, tell me 1 over 9. So let's do exactly that. There's your 1 out in front over the 9. And there's your winner. We've got it. Okay. Wow, a tremendous amount of work on the board there. But by now I'm hoping really it's clicking nicely for you. All of these conic sections are coming along pretty well. Great. Well, I will stop right there. Please try this out. See if you can pull it off. If you can get those characteristics, if you can work with the completing the square, you're doing great work. Hey, please, of course, let me know if you have any questions. And as usual, thank you so much for listening.